MPLS Layer 3 VPN with a static routing between P and C. In the previous video, I talked about how we can configure this scenario, and now I'm going to follow the packet. I'm going to discuss about to explain the, for example, exchange of routes in the service provider, and also I'm going to follow the packets in this scenario, and finally how we can verify the different features of the MPLS Layer 3 VPN with a static routing between P and C. The first thing that we should talk about that, for example, if one of the PCs, for example VPC1, send a traffic destined to the 192.168.20/24 network, how this packet can transport from the service provider. Let me to follow the packet. For example, assume that in VPC1, okay, we are using this command. VPC1 has the IP address of 192.168.110/24, and also VPC2 or VPC3, this is the VPC3, okay, has this IP address 192.168.210/24. The question is that when we are using this command, for example, in VPC1, maybe you need to send a traffic to the VPC3 with this command ping, okay, 192.168.210. You know that when we are using the ping command, this means that we need to send ICMP echo request, okay, ICMP type 8 message to the destination. ICMP echo request, then we have IP address, the IP header, and we need to send this packet from the VPC1 to the VPC2. And also in the IP header, we have source IP of 192.168.110 to the destination IP of the 192.168.210. Okay, this is the packet that should be generated in the VPC1, because VPC1 can understand that the destination is outside of its network, because you know that VPC1 first should compare the network ID part of its IP address with the network ID part of the destination IP, and it can find that the destination is not present in the VPC1 network. You know that 192.168.2 is different with 192.168.1. Because of that, VPC1 should send this traffic to R5 as its default gateway. Let me to show you VPC1 sending this traffic to the R5. This is the ICMP, okay, plus IP packet, normal packet, data or our original data, ICMP plus IP to the for example router 5. Router 5 is the default gateway of the VPC1. After that, VPC1 should forward these packets. R5 as a router can compare destination IP with the routing table of itself. You know that in R5 we configured one static route for example 192.168.20. How we can check the R5's routing table? It's so easy. We can use this command, show IP route. Look at here in router, we can use show IP route. Let me to show you in the R5, the routing table of R5. This is the R5 router, and then we can check the routing table, show IP route. In routing table of router 5, we have one static route. This static route says to us that if a traffic received for the 192.168.20/24, you should send it to the 10.151, okay? 10.151 is available on the interface ETH00 of the R5. Because of that, R5 should send this traffic toward R1, and now R1 receives this traffic. And now you know that the first step is that R1, okay, should forward this packet, the original packet, without any change in the packet, to the for example R1. This is R5, okay, and then it should send to the R1. R1, you know that R1 has one VRF A1 and interface ETH01 is one of the members of the VRF A1. Okay, you know that we have VRF A1. Because of that, R1 should compare the destination IP with the VRF A1 in with the routing table of VRF A1. Let me to show you the VRF A1. You know that R4 sends the network of 192.168.20/24 to the R1. Because of that, in the VRF A1 of R1, we have one receive routes from the BGP for the 192.168.10/20/24, okay, with the next hop of the 192.168.2541. Why? You know that we have neighborship between R1 and R4, and R4 sends this BGP update to the R1 because R1 now in the VRF A1 has this update. Let me to show you how we can check the routing table of the VRF A1. It's so easy. We can use show IP route VRF A1. Let me to show you in the router 1, show IP route VRF A1 in R1, en show IP route VRF A1. Look at here. In VRF A1, we have one receive routes for the 192.168.20/24 with the next hop of 192.168.2544. Okay, and you know that this network, okay, is not available in the look at here, we can't reach to these networks from the VRF A1, as you can see, and this means that we should send traffic to the 192.168.254.4 with a different method, okay, not with the normal IP routing. Let me to show you. You know that for reaching the 192.168.20/24, we should use this next hop, okay? But this next hop, 192.168.254.4, is not available in the VRF of A1. But this route is available in the, for example, global routing table. Let me to show you the global routing table, show IP route. You can see that this this IP address available in the global routing table, okay, and you know that we learned these routes in the global routing table from the routing protocol of OSPF. R1 knows that it should send this traffic to the, for example, it should send the traffic to the 192.168.254.4, but it can send directly from the VRF A1 to the VRF to the global VRF, because assume that, for example, R1 forward this traffic to the R2, okay? Let me to show you. Assume that this is not happening, but assume that R1 send this traffic, the ICMP, okay, with destination IP of the 192.168.210 from 110 to 210. Assume that R1 forward this traffic without any extra, for example, tag or label to the R2. Because R2 doesn't have the VRF A1, R2 doesn't have the destination IP. Let me to show you. Look at here. In the R2 is a core router. We didn't configure VRFs in the core routers. Show IP route can show us that the 192.168.20 is not available in the routing table of R2, and also we don't have any VRF on R2. Because of that, the traffic, if we send the traffic to the R2 directly, should be dropped, and this is not a good condition. Okay, how we can send this traffic to the R2? Because if you want to send traffic to the 192.168.254.4 according to the show IP route in the router 1, okay, we should send it to the router 2. Okay, for reaching to the 192.168.254.4, we should send this traffic to the router 2. But router 2 doesn't have a route for the destination of 192.168.210. How we can send the traffic to the router 2, and after that router 2, router 2 can forward the traffic toward the destination IP. Here we are using the for example, MPLS labels. How we